It's like old times again. Here I am. So, guys and gals, last night your assignment was to finish lesson 2 or to do the independent practice for lesson 2. So let's go over those answers before we start today's lesson. All right, so you were supposed to play this little spinner game. Okay, spin each spinner once, multiply the answer. So everybody's answers are going to vary because, of course, you all had different spinners. All right. However, our answers down here are going to all be similar. Okay, now again, the answers are going to vary. Some of you for part A said the answer was 7 out of 15. Others of you said it was 8 out of 15, or another group of you, it may have been about 9 out of 15. If you had something drastically different from those, I'm going to be concerned. All right, but those should have been, most of you should have had answers in that area. And then we had part B, and it says to estimate the probability of getting more than an 8. So if you had had in part A 7/15ths, then your answer to B will be 8/15ths. If your answer for part A was 8/15ths, then your answer will be 7/15ths. And let's suppose your answer had been 9/15ths. Now in part B, your answer will be 6/15ths. All right, so in other words, these two answers from part A and part B should add up to 15/15ths. So even if you had something different in part A, check to see if your numerator and your of part A and your numerator of part B add up to 15, then you've done it right. All right, so now part C, what's the estimate for the probability of getting the product of exactly 8? Well, it's either going to be 1/15th or 2/15ths. It's going to be really low. You should have a very small number. It should be 1 or 2, maybe 3. That would be really pushing it, but 1 or 2. All right, let's go to the top of the next page. And for letter D, what's the most likely product for this game? Most likely you would have gotten a 4, a 6, an 8, and a 12. Those were the most likely outcomes. If you played this a game again, right, you played it another 15 times, do you think you're going to get the exact same results? No. Every game is going to be slightly different. They're going to be close, which is why I said we're going to all have answers around the same parts, but they're all going to be slightly different. All right, so then number 2, we have a survey. We have our data here in our bar graphs. They're quite lovely. So how many students were surveyed? So I added up all the numbers, and there were 31 students in the survey. How many students said they liked snakes? There were 5 kids who said their favorite pet was a snake. Then we get into doing some probabilities. What's the probability that you're talking to a student that says dog is their favorite pet? So the probability of having a dog, right, was 9 out of 31, which is about 0.29 or 29%. You have a 29% chance of picking someone who said dog's their favorite pet. What about gerbil? Well, there was only 2 out of the 31 kids who said gerbils, so that's about 0.06. Again, these are estimates, and that's 6%. What about part E? Part E said, what's the probability of having a student pick frog? Well, frog wasn't even an option, so there's 0% chance of that happening. I had you guys skip number 3, so let's jump across the page, go over to page 17, and check our answers for number 4. Okay, so we have this student who did all these spins, and we got to figure out which spinner did they use, A, B, or C. Well, the number 1 showed up 6 times. The number 2 showed up 6 times, and the number 3 only showed up 3 times in all of our data. So based off of that, I know that parts 1 and 2 have to be about the same size, and number 3 must be smaller, and that is why I picked spinner B, right? The numbers 1 and 2 showed up the same number of times, and they have the same area in this spinner. And the number 3 was small, and sure enough, it showed up the fewest number of times. All right, I will check that with you guys when I come back to school on Monday. Let's jump over to page 18. Let's start our lesson. So there's our EQ. What does it mean for events to be equally likely? Go ahead, pause the video so that you guys can get down that EQ. All right, let's start. So Jamal, a 7th grader, wants to design a game that involves tossing paper cups. Jamal tosses a paper cup 5 times and records the outcome for each toss. An outcome is the result of a single trial of an experiment. Underline that. If you happen to have a highlighter with you, you can grab a highlighter. Let's get that. Okay, an outcome is the result of a single trial of an of an experiment. And so here are the results of each toss, right? So we just tossed it those few times. Jamal noted that the paper cup could land in one of three ways: on its side, right side up, or upside down. The collection of these three outcomes is called the sample space of the experiment. The sample space of an experiment is the set of all possible outcomes for the experiment. All right. So in this particular experiment, he has three possibilities. He has three possible ways, right? So his sample space has only those three things. It can be on its side, right side up, or upside down. When you flip a coin, you only get two choices. It's either heads or tails. The sample space when drawing colored cubes from a bag, if there's 3 red, right, 2 blue, 1 yellow, and 4 green, it's just each of the colors. It doesn't matter how many there are. Just every color in there is a sample. All right, so let's answer a couple questions here. For each of the following chance experiments, list the sample space, i.e., in other words, all the possible outcomes. So drawing a colored cube from a bag with 2 green, 1 red, 10 blue, and 3 black. The number of them does not matter, but we're going to have green, whoop, wrong color, green. We will have red. There will be blue. And there is black. Again, the number of them doesn't matter. It's just that I know if I was going to draw one out, I have a chance of a green, a red, a blue, or a black. I don't have a chance to get yellow. All right, tossing an empty soup can to see how it lands. So think about, this is kind of like the game that Jamal was thinking of here. So it can land when it's going to be facing up, right? The open part will land up. We could have the open part land down, and it can land on its side. Again, they're not necessarily equally likely, but they are all the possible ways it could land. Top of page 19. Shooting a free throw in a basketball game. Well, if you are shooting a free throw, you can either make it or miss it, right? Make and miss. Those are the only two choices you have. How about rolling a number cube, aka a die, right? We have one die, 2 die or dice, but we only have one. What are the different possible ways we could roll that? We could get a 1, we can get a 2, we could get a 3, we could get a 4, we could get a 5, and we could get a 6, right? Because this is a 6-sided die. What about selecting a word, right? I put letters on pieces of paper and I put them in a hat, and the letters I wrote in are probability. Okay, well, I could get a P, I can get an R, I can get an O, I could pull out a B, I could pull out an A. I've already talked about the B, so I don't have to say it again. I can get an I could get an L. I already have I in my list, so I don't need it again. I could do T, and I could get a Y. All right, so those would be all the possibilities of getting probability. Now, are they all the same chances? No. What about this spinner? What are the samples? What would be the whole list of every possible thing I could spin on the spinner? 1, 2, 3, 4, 5, 6, 7, and 8, right? All the numbers 1 through 8 will be our sample space. All right, top of page 20. The sample space for the paper cup toss was on its side, right side up. So in other words, having it so it faces the correct way, and upside down, where the top, where you would drink out of, is down. Do you think that each of these outcomes has the same chance of occurring? If they do, they are equally likely to occur. The outcomes of an experiment that are equally likely to occur when the probability of each outcome is equal. I want you guys to underline or highlight that. Okay, equally likely, which is the question from our EQ, means that each event has the same probability. Every single one of them has the same chance of happening. So you guys are going to get a paper cup. You're going to toss it 30 times and just write down if it landed the right side up, where it's facing, the way it would if you were going to drink out of the cup. if it's going to be on its side, right, like you had tipped it over, or if it's upside down. Don't try, this is not like the water bottle flip like you would do in school. This is not that. We don't want to try to make the results be what they, what you want them to be. Just let them naturally happen. Okay, so I'm going to give you guys, I don't know, 5-7 minutes to do this, and then we're going to get together and talk on page 21. So go ahead, hit pause, hand out the cups, and do this experiment. So now that your experiments are done, let's go over and try to figure out what's going on here. So using the results of your experiment, what's the estimate? What's your estimate for it landing on its side? So we're going to write the probability of landing on its side. Right? I'm going to move on here, but you guys will fill this in. Then for part 8, we want the probability of landing down. And of course, 9 is the probability that it lands up. And based on the results, do you think they are equally likely or not equally likely? So I'm going to give you guys, I don't know, maybe 2 minutes here to quick fill this in. Every single one of us is going to have a different answer, slightly different answer. They're probably going to be around the same spots, but not necessarily. But we do know that we're all going to have 30 as our denominator. And if you change them over to a percent, awesome. But based on this, did each one, side facing down or facing up, were they equally likely? Did you get the same number on all 3? Like, did you get 10, 10, and 10? Probably not. So based on the results, these are not equally likely. Okay, they are not equally likely. They didn't all have the same chance of happening. All right, top of page 22. Top of page 22. Using the spinner, answer the following questions. Are the events of spinning and landing on 1 or 2 equally likely? Didn't ask about 3, just 1 or 2. Yes. Because they have the same space, right? They take up about 1/4 of the whole circle, right? If I imagine that cutting that over, right? Because they have the same size space, right? 1/4 of the circle. Are the events of getting a 2 or 3 equally likely? No. No, right? Because the 3 is larger, right? The 3 is larger. In fact, it's half of the circle, right? And that's not the same, right? It's greater than the 1/4 for the 2, right? This is the 3. The 3 has half the circle, and the 2 only has 1/4 of the circle. How many times do you predict the spinner will land on each section after 100 spins? So I would think that it's going to land on the number 1 about 25 times, right? Because it's 1/4 of 100. 1/4 of 100. This is what I think would happen. I don't know for sure until I spin it. All right, the number 2, how many times do you think that's going to happen? Well, it's the same size as 1, so I would imagine it would be about 25 again, because again, it's 1/4 of that size. But what about the number 3? I think the number 3 is actually going to happen about half the time, right? Because it's about half of the circle. So I would imagine it would be around 50 because it's half of the 100 times I'm going to spin it. That's just what I predict. I don't know for sure. So now it says to draw a spinner that has 3 sections, right? We're going to put a 1, a 2, and a 3 in it so that when the spinner is spun, we think that we're going to get the same number every time. Okay, so do the best you can at drawing a circle. There's my circle. And I'm going to draw this into 3 parts. Well, I need my 3 parts to be equally likely, which means the 3 parts are going to have to be the same size. All the same size. So I'll put a center in there, and I'll do the best I can at drawing into thirds, right? 1, 2, and 3. They're not exact, but they're pretty close. If I wanted to, I could get a protractor out and get them to be exact, but we're close enough. All right, so I would like you guys to do your homework. Your homework is going to be found on pages 23 through 25, right? You guys are going to do pages 23 through 25, all for the homework, and I will see you guys on Monday.